What's up, everyone? We are continuing talking about solving systems now with our third method by elimination. So, if you haven't checked out our other videos, we solved by graphing first to help us get a feel for what the heck's going on there in the visual aspect of solving systems, getting to see what in the world does one solution, no solution, infinitely many solutions look like. Then we jumped into substitution, and now we're going to look at solving systems by elimination, which is my personal favorite. All right, so what the heck is going on here? Steps for solving a system by elimination. We're going to get x's and y's on the same side of the equation and the constants, the numbers, on the other. So technically this is the standard form, if you remember talking about that. It's a little bonus nugget. All right, then we're going to stack the equations so that opposite variables are lined up. I must be writing really big today because it totally fits in my blank in my handwritten copy. Oh well, opposite variables are lined up. All right. Oh my gosh, that's not what it's supposed to say. That's so embarrassing. No wonder it didn't fit. Oh my word. All right, so we're going to stack the equations so that, oh my terms. Oh my word. You know what? I'm just going to keep that in there because we all make mistakes. So, you know what? If I was in front of my real class right now, we'd just be owning it. So, whatever. Now, here's where we're looking for those oppo variables. Opposite variables. Like if I have negative 3x and positive 3x. Then we're going to add our equations together. So one variable should cancel out, aka get eliminated, which is where the name of this method comes from. I'm always saying in math, we don't use cutesy names. We tell it like it is. All right, it's like I named my kids Son 1 and Son 2, right? Instead of coming up with cute names. All right, now we're going to solve for the remaining variable. You're going to substitute your answer into one of the original equations to solve for the other variable, and you're going to check your solution in both equations, right? Got to make sure we did everything correctly. All right, so let's get into it. So first thing going on here, I've got my my system. They're both in standard form. They're stacked, right? So like terms are lined up, and lo and behold, y'all, we got some opposite variables. See, we got that negative 5x and the positive 5x. Those are opposites, which means when we add these together, they're gonna cancel out. Okay, so let's go ahead and add these guys together. So I always use sound effects with my students, right? So that one is going to cancel out. Then we have 7y minus 2. So that's going to be 5y equals 32 minus 2, 30. Now we just have to solve for y. So I'm going to divide both sides by 5, and I'll get y equals 6. Cool, halfway there. So now what we're going to do is either equation 1 or equation 2, top or bottom equation. We're going to go back and plug this in. Why not use the top one? It's just there. So I'm plugging in this value of y so that I can solve for x. So yeah, negative 5x plus 42 equals 32. I'm going to subtract 42 from both sides. We're going to have negative 5x equal to negative 10. Divide both sides by negative 5. Get x is equal to positive 2. All right, so what we need to do, your teacher may be totally fine with you leaving those as separate, right? X equals, Y equals, or they might ask you to write your answers in ordered pair. So you're going to have to check with them to know what's going on. But one thing that I am certain of is their prob's going to ask you to check your work, right? So what we're going to do is we got to plug these guys in for x and y in both equations. And we use this little question mark over the equal sign because we hope it ends up being equivalent, but we're not quite sure yet, right? So we got to check that out. So let's plug these guys in. So remember, we're using 6 for y and 2 for x. And let's see what happens. This becomes negative 10 plus 42. And of course, that does add to 32 equals 32. So we know it works for this top equation, but we got to check the bottom equation as well. So this will be 10 minus 12. And that is going to be negative 2 equals negative 2. Woo-hoo! So we know it works. Like I said, your teacher may be fine with you leaving your answers separate like that, or they may prefer an ordered pair. Just make sure you know whatever floats their boat. Alrighty. On to the next one. Alright, so first thing, both of our equations are in standard form. Nobody's got oppo variables right now, though. So if we look at, call this equation 1 and equation 2, no one's got oppo variables quite yet. So what I'm going to do is if I multiply my top equation by negative 2, then my y's will cancel. So let's start there. So I'm going to take my top equation and I'm going to multiply the whole thing by negative 2. And I'll just rewrite it down here. So I got negative 2x plus 2y equals 6. All right, and now I'm going to add those up, right? So I'm adding these equations right here, this one and my new equation 1. So this is going to cancel. Oh, this is going to cancel. Oh, and this is going to cancel. So everything canceled out and I ended up with 0 equals 0. So what this is this is a true statement, right? This is always going to be true no matter what I end up plugging in for x and when I plug in things for x and y, right, this is always going to be true. So this is a true statement. So there's going to be an infinite number of solutions. So this guy has infinitely many solutions. There's infinite number of pairs that is going to make this work, right? As many ordered pairs as are on the line. Okay, if we think about graphically what's going on here, we have 2 coinciding lines, right? One right on top of each other. Very nice. All right, example 3. Let's go ahead and solve the following system by elimination. All right, notice here, this always trips up my kiddos. This one here is not in standard form. So notice how my equal signs aren't like lined up and my like terms aren't either. So we got to be careful with that. So let's go ahead, rearrange. I need to get this 4y on this side of the equation. So I'm going to do that by subtracting 4y. So I'll have 3x minus 4y is equal to negative 11. All right. Alrighty. So now, this is my equation 1. This is still equation 1. It just got rewritten. Equation 2 also has a 3x. So if I multiply equation 2 here by negative 1, then I'll be able to have those opposite variables that we're hoping for. And now we can add them up. So my x's are going to cancel. Oh, no. This happened last time too. Everything's going to cancel on the left-hand side. But what happens over here is I'm going to end up with 8. Okay, so I get the statement that says 0 is equal to 8, but that's never going to be true. There's not going to be a single ordered pair that I could plug in that's going to make that be a true statement. And so what this means is that we have no solution. Your teacher might also accept the empty set symbol here. And so what that means is graphically, if we think about this, we have two parallel lines, right? They're just running in tandem. They're never, ever, 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 ever going to touch because their slopes are the same. Their y-intercepts are different. Alrighty, friends, so go ahead. We need to take example 4 here. Try it out on your own. I'm telling you, you're going to do a great job. But yeah, try it out. All right, I see you not actually pausing the video, trying it yourself. Come on, guys. All right, let's go for it. So first things first, both of my equations are already in that standard form. X's, and then the y's, and the equal signs. They're all stacked up, like terms on top of each other, right? X's over x's, y's over y's, constants over constants. All right, so what I'm noticing here is that this one on the top has a negative x already, which is good. And this is a positive x. All I need to do, though, is if I multiply that top equation by 2, then we'll have opposite variables. So let's multiply this whole top equation by 2. And I'm lazy, so whenever I can get away with not writing that bottom equation again, that's what I'm going to go for. So I'm just going to write my new top equation down here. So this is going to be plus 8y equals negative 2. And now I can just add it with the bottom equation. And they're already lined up. So those x's cancel. Beautiful. End up with 5y is equal to negative 5, which means that y is equal to negative 1. So I'm going to take this beauty here, and I'm going to plug it into one of my OG equations. So let's go with the top one because, like I said before, I don't know, it's the first one I saw. I'm just kind of lazy. Oh, what am I doing? Messing up my color coding here. So let's go. Negative x plus 4y equals negative 1. All right, I'm plugging my y value in there. Just like negative x minus 4 equals negative 1. You can add 4 to both sides. We'll get negative x equals 3. If I divide both sides by negative 1, I'm going to get an x value of negative 3. Now, before we get too carried away, let's make sure we check our work. Gotta check for both of them. So, top equation, bottom equation. So let's get negative x plus 4y is negative 1, we hope. 2 times x, whoa, what am I writing here? Minus 3 times the y, we hope, is equal to negative 3. Let's plug in those values for x and y. Negative 3 -1. Alright, so this becomes 3 minus 4. And that is going to be -1 equals -1, so it works for the top one. Over here, this will be -6 plus 3, which is going to be -3 equals -3, which means that one worked out too. Woohoo! So like I said, your teacher might prefer an ordered pair, so just know what's what, right? Personally, in my classes, I accept either. All right, and there you have it. So look at that, y'all. We just solved all those systems by elimination. Great job, everyone.